Okay, so year 7, welcome back to our daily lesson, and now we are in lesson 10.8, which is going to be the last lesson for unit 10. So if you have your books with you, please open your books to page 158 to page 159. The title of the lesson today is Energy is Conserved. So we will start again with memorizing the 2 principles of conservation of energy. So in our previous lesson, we talked about the first principle, which states that energy cannot be created or destroyed. It can only be changed from one form to another. And this time we will further understand the second principle, which is about in any change, there is the same amount of energy after the change as there was before the change. Let me read that to you again. In any change, it means in any change or transform of energy, there is the same amount of energy after the change as there was before the change. Teacher, doesn't make sense to me now. What does it mean? That's why we're here. We're trying to understand the second principle of energy conservation by using examples later on. So first things first, we measure energy using joules. This is named after Mr. James Joule, who made important discoveries about energy. Okay, so how do we write down joule? It's just a capital J. Okay, so it says here in the photograph, we have a digger in one of a building site, and it digs and pushes soil. Also, it lifts some bricks and maybe heavy stones. So the digger needs a supply of energy to do these things. It gets energy from the diesel fuel in its tank. So again, for this specific digger to work, where does it get its energy from? So in its tank, we have diesel. Diesel is a fuel, okay? And we all know that fuel is a chemical store of energy. So again, what does the digger do? It lifts and pushes and pulls things, and as it works, the engine or the machine inside the digger becomes hot, and the heat energy goes out to its surrounding. So let me read the question again to you. Diesel is an energy store. So what form, again, just a quick review, what form of energy is stored in diesel? If you listened to me carefully a while ago, you should know this. Good job. Diesel is a chemical store of energy. So how can you tell that the digger is doing work? What is the work that has been doing? Okay. Yes, the digger lifts, pushes, and pulls things. And the digger is also raising a heavy load of things in the construction site. Okay, let's go back again to that second conservation of energy principle. In any change, there is the same amount of energy after the change as there was before the change. So if you want to put things into two, we have before the change, we've got after the change, and the middle ground is the change itself. So in any transformation of energy, there is the same amount of energy before, and there will be the same amount of energy after. Let's take a look into details. So again, the digger pushes and pulls things to do its work, and the engine gets hot and energy goes out to its surrounding. So how do we know that? So we have to put numbers. We have to quantify how much energy is there inside the tank of a digger. So the diesel again, which is the chemical store of energy inside the tank of the digger, has 10 million joules of energy. And as it works, it is being burned so that chemical reaction happens, and then 5 million joules transferred to the work that it is done. And 5 million joules is being transferred as the heat in the engine that is released through the air. So see, inside the tank, 10 million joules. And then change happens. And then we've got 5 million joules for the works it has been doing, and 5 million joules to the heat that was transferred to its surrounding. So same amount of energy before the change and after the change. 10 million joules in the fuel, then we got 5 million joules for the work, and then 5 million joules to the heat that has been transferred to its surroundings. We can also show the energy that an object or a person has used using energy arrows. Again, an energy arrow is used to show the energy used by a person or an object. So, using the same example that we have with the digger, at the start, as you can see here, the diesel inside the digger's tank is 10 million joules, and the arrows is equally split into two. We've got 5 million joules that was changed into work that it is doing, and then 5 million joules was transferred to the heat that is being sent out to its environment. So 10 million joules at the start, and the energy it has transformed into has a total also of 10 million joules. Okay? Again, as a review, in any change, there is the same amount of energy after the change as there was before the change. Again, let's all read this together. 1, 2, 3. In any change, there is the same amount of energy after the change as there was before the change. And now it's your turn. So please go to ThinkWave and open your assignment for week 17B. And you will be answering some questions regarding energy arrows. So here is a quick description of the situation you need to answer. Let me read to you. We eat food to give us energy we need for life. We need energy to keep our bodies working and to do physical activities such as walking, carrying, and pushing. Most energy escapes from our body as heat. So question number 1. The arrow here shows the energy used by a young person in 1 second. Remember that energy is measured in joules or in capital J. So get your notebooks and answer the following question. Question 1A. How much energy does this person use each second? Question 1b. How much of this energy is used for physical activity? Question 1c. How much of this energy is spread out from a person's body as heat? And question number 2. An athlete needs a lot of energy to run fast. Here is the arrow diagram for a person who runs a marathon. So every second he uses 200 joules. 20 joules is used in running, and 180 joules is spread out as heat to the environment. Now explain your answer in question 2a. How can you tell from the diagram that the runner uses a lot of energy? Okay? So you can answer in your notebook in a form like this. You have to write your name and your class, and then questions 1a, b, c, and then questions 2a. When you're done, you have to take a photo of your work and submit it in ThinkWave. Again, it's in week 17b. The highest point for this activity will be 10 points. Okay? You will be getting as high as 10 points when your work is submitted before this period ends. And if you want to take more time and you submit your work before 3:30 p.m. today, after this period, they can have additional 3 points. So choose the best option for you. Thank you very much for listening today, and I hope to see you again in our next lesson. Bye, guys.